Now we're going to find the LCM using the prime factorization method. Again, if you need to, refer back to how to find the prime factorization of any number using a factor tree. So 100, for instance, would be, let's see, I can do it. I don't want to do it in my head, but I'm doing it in my head. I think it's 2 squared times 5 squared. And 12 would be 2 squared times 3. So now let's talk about a little trick you can do to find the GCF and the LCM in one problem using the prime factorization method, which is my favorite method because it knocks out 2 birds with 1 stone. Don't worry, it's not really harmful to those birds. They were very bad birds. They don't do their homework. What are you going to do? The way you do this for both methods to work the GCF and the LCM is you fill in what's not there. So for instance, in the list of 100, there's no 3. So you could put a 3 in there, but then you put it to the 0 power because 3 to the 0 is 1. Remember that a to the 0 equals 1 as long as a itself does not equal 0, which we're not going to have. And same for 12, there's no 5. So you can fill in the gap by putting a 5 to the 0 because, again, 5 to the 0 is 1. So if you do this, then the way to know the GCF or the LCM is based on the power. In this problem, we're finding the LCM. So comparing the, let me actually rewrite this so it's a little bit easier. Let me rewrite 100. Oh, I did it in green. Let me go in order. So we would say 2 squared times 3 to the 0 times 5 squared. And then for 12, we could say 2 squared times 3 times 5 to the 0. All right, that's better. So now we have the primes on top of each other, a little bit easier to read. So in terms of the LCM, the way you find the LCM is you take the larger exponent. So comparing the 2's, we have 2 squared and 2 squared. Doesn't matter which one you take, I'm going to take that one. Comparing the 3's, we have 3 to the 0 and 3 to the 1st. 3 to the 1st is bigger, so I'm going to take that one. And then comparing the 5's, we have 5 squared and 5 to the 0. Again, for the LCM, you take the larger exponent. I'm going to take 5 squared. So, writing it down, the LCM would be 2 squared times 3 times 5 squared, which is 300. So the smallest number that both 112 divide into would be 300, which answers the question. But if you also wanted to find the GCF, instead of taking the larger exponent, you would take the smaller exponent. Well, notice as we did it, the remaining ones that we didn't highlight, now I'm highlighting in pink here, would be the GCF. So you'd say for the GCF, you'd say 2 squared times 3 to the 0 times 5 to the 0, which is just 4. So this method, dividing by prime, the prime factorization method, does knock out both cases of the GCF and the LCM. Let's do this again for 112 and 72. If you were to factor 112, you would get 2 to the 4th times 7. If you were to factor 72, you would get 2 to the 3rd times 3 squared. So to make them have common primes, I'm going to put in a gap of 3 to the 0 for the 112 number. And I'm going to put a gap of 7. Ugh, that's supposed to be a 3. Nailed it. Into the 72. So now for the LCM, take the larger exponent. We are comparing 2 to the 4th and 2 cubed. Which one's bigger? 2 to the 4th. Comparing the 3's, we have 3 to the 0, 3 squared. Take the bigger one for the LCM, 3 squared. Comparing the 7, 7 to the 1st, 7 to the 0. By the way, they're all not going to be that pattern of top, bottom, top. That was just coincidence. So we get 2 to the 4th times 3 squared times 7, which is a number. I know that's hard to believe that it's a number, but it totally is. I got 1008. The ones that were not highlighted, even though they didn't ask for it on this slide, is the GCF, which would be 2 cubed times 3 to the 0 times 7 to the 0, which is just 8. So this is my favorite. You can pick your favorite, of course, but I like this because it knocks out both problems.